The OV is general trends inside of organic chemistry, and you will understand 90% of all the reaction mechanisms inside of your class. You'll be tested at the end of the video for your mastery over these vital mechanisms. Okay, so the first mistake that I often make is that I don't know what a Lewis base and acid are. So just to get it clear, a Lewis base is an electron donor and an acid is an electron acceptor. To be more specific, the Lewis base is negatively charged and the acid is positively charged. This is vital because the common mechanisms that are reaction mechanisms would be the active proton transfer, or the transfer of positively charged hydrogen cations from a base to an acid. For example, take Gabriel synthesis. In the initial second reaction, this proton transfer occurs when a metal oxide, which is a Lewis base, meaning that there's a high density of electrons, as there is an ionic bond between the potassium and the oxide, reacts with an amino group, which is the acid, as hydrogen forms a polar covalent bond with nitrogen. Another example would be the addition of hydrogens to an alcohol group from an acid like hydrochloric acid. This is because oxygen has such a high density of electrons, but acids lose their hydrogens to these oxygens, as these hydrogens are in situations where they're in an extremely unequal polar bond, and when they break off, they lose their only electron. Therefore, they're ultra positive, and why we also call them protons. This is also called protonation. The next mechanism that you need to know would be dissociation, in which molecules split because it's simply more stable by itself than with the rest of the molecule. For example, the leaving group forming CO2 or water. So let's take decarbonylation, for example. A reaction where a carboxylic acid disassociates the rest of the molecule after being heated up and transforming into CO2. In the transition state, the carbon has 5 bonds. It could either A, form CO2, which is exceedingly stable, but it breaks off from the rest of the molecule, or B, break off one of the hydrogens, forming an anion, which is not energetically favorable, but at least it stays on the molecule. It'll choose A simply because CO2 seems like a better choice than forming an unstable ion. So why do carbon splits and why dissociation happens? This is the same with alcohols after being protonated. Next is a nucleophilic attack. So essentially, nucleophiles love negatively charged areas, like the nucleus of an atom, and electrophiles love electrons. And they kind of simply positive areas like negative areas and vice versa. Example, in SN2, any negatively charged molecule should instantly go attack a partially positive location of a molecule and then cause a reaction to occur. For example, a metal oxide reacting with a haloalkane, because the haloalkane forms a polar covalent bond, which causes a partial positive charge to be assigned to the carbon bonding to the halide. Along with that, any negatively charged atoms usually go towards positively charged areas, such as carbocations, and fuse with the molecule there. And lastly, rearrangement, a common form could be the hydride shift. Essentially, carbocations within a reaction intermediate would switch with a hydrogen at a more stable position, such as a tertiary position, if it is a primary position, to make it more stable for the molecule as a whole. This allows the formation of Zaitsev and Hofmann products, and literally why some reactions have different products despite being the same things reacting. Plus, rearrangement, nucleophilic attack, dissociation, and proton transfer are the 4 common mechanisms that you have to know if you want to master organic chemistry to whatever degree that you wish to master it on. And if you want to do questions, well, you can always find them on my Anki deck, which I've made public. Go check it out on my linked tree.